All right, let me get up. Got my camera going. All right, let's see. Can you see? Yep. Okay. All right, this is Cop and Perp for Con Montero. So we've gone over this problem a number of times, just looking at it visually, but now we're solving it graphically. Professor taught us how to do that. So with the Cop and Perp, you got the position, velocity, and acceleration right here. Okay, all in a line. When it comes to position, Perp is going, pretty linear, and then the Cop picks up, and it's a curve. Because there was a slight delay on that. You have velocity, where the perp is stated to always be going about 20 meters per second. We have that up here. And then the cop should actually have a line here. So there's a 5-second delay. That's our T2 time, essentially. And so what ends up happening is the cop doesn't take off till that point, and at which point it passes, well, the velocity exceeds the perps, okay? And then for acceleration, constant acceleration for the both parties, being perp is at 0 and the cop is at 5 meters per second per second. Okay, what we're mainly focused on here is the area in which this is. Our professor David, he taught us how to look at this and turn it into almost geometry by looking at the areas. And that's how we can tell the final position or the time in which that it took it. So I'm going to work through this. We're going to get a quadratic formula, and then that will tell us how long it took that person, well, the cop, to pick him up. So let's work through it. So our known values are the velocity of the perp, 20 meters per second. Cop acceleration is 5 meters per second. And then the time, T2 is essentially 5 seconds after the perp had been going, and then he passed the cop. So also up here we have some equations, right? So the line, the angled line for the velocity of the cop, that is our slope. The slope of that is the acceleration of the cop, and then the area of the perp is this red rectangle, and the area of the cop is our blue triangle. So you'll notice that on my equations up here, basically base times height for the perp because it's a rectangle, and then the cop is base times height times half, okay, because that's how you get a triangle. I wrote it out already, so it is T3 minus T1, or T2 rather, apologies. Okay, because no, T1, yeah, because that is the base of that triangle. Okay, T1 is the farther to the left, T3 is the farther to the right. So now that we have those, we also know that the area for the cop and perp are equal. Okay, so we can set these equations to the same. So that's what I'm exactly going to do. We're going to start out with T3 V P is equal to 1/2 T3 minus T1 or T2 equals velocity of the cop squared. Okay, so that's our baseline starting equation. Okay, now we can break this down even further and plug in that acceleration formula for the slope into this VC squared, the cop. Well, velocity of the cop 2. I always mess that up. I always call it squared. That is 2, not squared. There is no squared right now. All right, so we're going to do that. I'm just going to equal that over. 1/2 T3 minus T2 equals, I'll do a bigger parentheses here. So AC times T3 minus T2. Brilliant. Moving along. Okay. Now that we've done that, we are going to move over the AC, the acceleration, as well as the 2. So basically I'm going to take this over here and over here. So we're going to divide by the AC over here, which means, and then multiply by this 2 here, reciprocal. So it's going to be 2 VP and then over AC times T3. Okay, brilliant. Okay, now what's that leave us on the other side, right? We have T3 minus T2 is, and then on the rest of it, T3 minus T2. All right, starting to look like a quadratic where we're going with this. So now we are going to shimmy these across. Distribute, I think the name is. Been a little out of practice of that. But basically we're going to move these over, basically cross multiply, that kind of deal. So we're left with T3 squared minus T3 T2 plus T2 squared. Okay, and it works out that way because we got two T2s, two T3s, so now we got some squares in, and then this middle conjecture is multiplying that all together. And then we'll set that back up, equals to velocity P over acceleration of the cob times T3. Okay, got our equation, moving along. Now, we will set all these to 0, essentially. So basically, we want to get 0 on this one side, so we need to move everything over. So that will come out to T3 minus T V P A C T2 plus T3 Okay, and then that will be equals to 0. Okay, almost done with the quadratic. So now we will add, we will start being able to plug in. So professor wants us to basically consolidate our equation down to it. So our final equation so far, before we add actual numbers in there, is T3 minus 2 parentheses velocity of the perp over the acceleration of the cop plus T2 and parentheses times T3 plus T2 squared is equal to 0. Now we're all squared up, going to 0. Okay, and so now we will start plugging in. So we don't know T3, but we do know everything else at this point. So ultimately it's T3 minus 220 meters per second, because we got that right here, over 5 meters per second plus 5, and then times another T3 plus 5 seconds. Okay, and then that is squared. So, and then that equals 0. Now we can consolidate everything in the middle like that. So essentially it comes out to, we consolidate the T3 and the minus part here. Okay, so it's T3 squared minus 18T plus 25. I think I did that right. Yeah, so basically consolidating it down. Now we have an official quadratic equation. So when we put that in to our online quadratic equation formula, let me see. That comes out to enter 16.5 seconds. And that is basically telling us how long it took our cop to catch the perp. That's that end right here, at the very end here. And we did that using the quadratic equation, which we plugged in the areas to solve it graphically, because we have the slope and we have the two areas. Let me pull this up for you guys. That's kind of what she looks like there. Work it down. All right. Well, thanks, guys. Appreciate it.